All right, so for anyone out there prepping for those senior software engineer interviews, you know they want to see more than just your coding skills. You really got to show them you can design stuff, like you can think architecturally.
Yeah, for sure. Like moving beyond just solving the problem at hand to thinking about building flexible systems that are easy to maintain and to expand on.
Exactly, and that's what we're diving deep into today. We're talking about a design pattern that comes up all the time in those senior level interviews. And really understanding it, it can help you stand out.
Definitely. And that pattern is the decorator pattern. And by the end of this deep dive, you'll know not only what it is, like how it works under the hood, but more importantly, when to use it. Like, why choose the decorator pattern? That's what those interviewers really want to hear.
Totally. So let's imagine we're building, oh, I don't know, like a menu system for a coffee shop app. Pretty common example, right?
Yeah.
So we've got our basic coffees. We've got, say, dark roast, house blend. But then the customer wants to add all the extras. They want mocha, they want whip, maybe soy milk, the works. And your first instinct might be to just go with inheritance, right?
Yeah.
You create a dark roast class and then a dark roast with mocha, dark roast with whip.
Right. And then before you know it, you've got like this huge explosion of subclasses for every possible combination.
Right. And that right there, that is the problem. That is what we call class explosion. It's a combinatorial nightmare.
Yeah, it becomes super hard to manage. Think about trying to debug a bug that only shows up in like the dark roast with soy milk and double whip class.
Oh my gosh. Yeah.
Plus, you got to test all those different subclasses. It just becomes a real headache to maintain, and it gets worse. It's not just about the number of classes, right? Inheritance, it creates this very rigid relationship between things. Like if a coffee is a dark roast with mocha, well, that's it. It's stuck that way. What if the customer decides, actually, you know what? Scratch the mocha.
Right. Or they want to swap it out for something else after the fact. It's not exactly easy to do with inheritance.
Not at all. And you might end up adding all these properties and methods to your base beverage class that don't even make sense for every type of coffee.
Yeah, like some features only apply to certain drinks, but you're forced to put them in the base class.
Right. It's like putting all-season tires on a race car. The base class gets all cluttered up with things that not everyone needs. So that's where the decorator pattern comes in. It's like this really elegant solution to this whole mess.
Okay, so how does it actually work?
The basic idea is you're dynamically decorating an object with extra responsibilities. And you're doing this at runtime, so on the fly. It's like you're wrapping the original object with these layers, and each layer adds a new capability.
Okay, so we're not creating all the subclasses anymore.
Right, exactly. So going back to our coffee example, instead of having a separate class for every combination, we start with just a plain dark roast object. Then, if the customer wants mocha, we wrap that dark roast with a mocha decorator.
Like adding a layer on top of the dark roast?
Exactly. It's like snapping on a Lego brick. And if they want whip too, we wrap it again, this time with a whip decorator. So you can just keep adding layers, and you can add them in any order. And that's a big advantage, by the way. It fits really well with this idea of composition over inheritance, which is kind of the preferred way to do things in a lot of modern software design.
So it's more flexible and adaptable.
Exactly. Now, the real magic here is how these decorators work. They work through delegation. So say you want to find out the cost of our coffee with mocha and whip. You ask the outermost decorator, in this case the whip decorator, hey whip, what's the cost?
And what does it do?
Well, the whip decorator knows its own cost, right? Let's say it's 10 cents. But it doesn't know the cost of the coffee itself, so it passes the question along. It delegates to the mocha decorator it's wrapping.
Okay, so it passes the buck down the line.
Exactly. And the mocha decorator, it knows its cost, let's say 20 cents. And it adds that to what it gets back from the thing it's wrapping, which is the plain dark roast. The dark roast knows its own price, say 99 cents, and it sends that back up the chain.
So it's like a recursive process.
It is. So the mocha gets the 99 cents from the dark roast, adds its own 20 cents, and returns $1.19 to the whip decorator. And finally, the whip adds its 10 cents and gives you the final price, $1.29.
Well, that's pretty neat. So each decorator does its own little thing, adds its own cost or whatever, and then passes the request down the line.
Right. And no single decorator needs to know the details of everything else in the chain. They just handle their own part. Now, here's another interesting thing about decorators. They share a common supertype with the object they're decorating.
Okay, what does that mean exactly?
So in our coffee shop, you'd probably have an interface, maybe called beverage, and both dark roast, mocha, and whip would implement that interface.
So they all kind of adhere to the same contract.
Yeah, exactly. And that interface would define methods like get description and cost. This is important because it means you can treat a decorated object like our dark roast with mocha and whip the same way you treat the plain dark roast. You can pass it to any part of your code that expects a beverage.
Right, because they all fulfilled the same basic contract.
Exactly. That's called the substitutability principle. It means you can swap in a decorated object wherever the original object is expected. And this leads to another really cool feature. Because of this wrapping and the shared interface, you can actually stack decorators. You can put as many as you want in any order.
So like you could have a double mocha.
Exactly. You just wrap it with the mocha decorator twice. And this all happens at runtime, so you decide on the fly which decorators to apply and how many. Plus, a decorator can do its thing either before or after it delegates to the wrapped object. Think about adding a scroll bar to a text area, for example. The scroll bar decorator, it would draw itself around the text area, so its behavior happens after the text area is drawn.
Makes sense. So it's not just about adding things on top. It can wrap things, go before or after. It's really flexible.
Exactly. Now, just to formalize this a bit, especially for those interview scenarios, the decorator pattern is officially defined as attaching additional responsibilities to an object dynamically. And this is key. It's a flexible alternative to subclassing when you want to add new functionality.
Right. Like in our coffee shop, we're not making subclasses for every combination.
Exactly. Now, there are a few key players in this whole pattern. You've got the component, the concrete component, the decorator, and the concrete decorator.
So let's break those down.
Sure. The component, it defines the basic interface for the objects that can be decorated. So like in a UI, this might be a visual component with methods for drawing and resizing. Or in our coffee shop, it's the beverage with methods like get description and cost.
So it lays out the ground rules, the basic contract.
Yeah. Then you have the concrete component, which is the actual object being decorated. So this could be like a text view that implements visual component. Or in our case, our dark roast that implements beverage.
Okay, so that's like the core thing we're starting with.
Yep. Next up is the decorator. This is usually an abstract class, and it also implements the component interface. And importantly, it holds a reference to a component object, the one it's wrapping.
So it's like the generic decorator. It knows it needs to hold on to something, but doesn't specify what kind of decoration it is.
Exactly. It provides this sort of blueprint for all the specific decorators. And then finally, you have the concrete decorators. These are the guys that actually add the specific behaviors. So for example, you might have a border decorator that adds a border to a visual component.
Or our mocha and whip decorators for the coffee.
Precisely. Each concrete decorator holds a component object, the one it's wrapping, and it overrides the necessary methods to add its own functionality. And it often does this either before or after delegating to the wrapped component. And the key here is that hat-to-A relationship. Each concrete decorator has a component that it wraps. That's the heart of this whole pattern.
So if we're thinking about those technical interviews, why is it good to bring up the decorator pattern? Like, what are the benefits you can highlight?
Well, the biggest one is flexibility. It's way more flexible than inheritance. You can add and remove features at runtime. You don't need a new class for every combination.
Right, so we avoid that whole class explosion issue.
Exactly. So instead of having separate classes for like bordered scrollable text view and bordered text view, you can just have a text view and wrap it with border decorator and scroll decorator as needed.
Much cleaner.
Yeah, it makes your code way easier to maintain and understand in the long run. It's also a pay-as-you-go approach to features. You start with a simple component, and you only add what you need when you need it by applying the decorators. So your core classes stay lean and focused. You don't have all this bloat from unused features.
And as you mentioned before, you can mix and match decorators however you like. You want a double border? No problem. Apply the border decorator twice. This is way harder to do with inheritance. It can get really messy really fast.
Absolutely. But like anything in software design, the decorator pattern isn't a silver bullet. It has trade-offs, and interviewers like to see that you understand those.
So what are some of the downsides?
Well, one thing to keep in mind is that a decorated object, it's not strictly identical to the original component when it comes to object identity. Like if you have code that checks if an object is a text view and expects it to be only a text view, then wrapping it with a border decorator will break that check.
Because now it's a border decorator that contains a text view, not just a plain text view.
Right. So the best practice is to code against the abstract component interface as much as possible. That keeps things flexible.
Make sense? Are there any other downsides?
Another potential issue is that you can end up with a lot of small objects. You have your original components and then maybe multiple layers of decorators wrapping them.
Which can make things harder to follow.
Yeah, it can make the system a little harder to understand and debug, especially if you have these really long chains of decorators. It might not be obvious which one is responsible for what. It's like having a bunch of little boxes all nested inside each other. Each box has its purpose, but figuring out the overall structure takes a bit more effort.
So it's a trade-off between flexibility and complexity.
Exactly. Now let's talk about where we see the decorator pattern in the real world. One of the most common examples is in Java's input-output IO library.
Oh yeah, that's a classic one.
The java.io package, it's like a textbook case of the decorator pattern. Think about reading data from a file. You might start with the file input stream, which is your concrete component. It handles the basic reading of bytes from a file.
Right.
But what if you want to improve performance by reading data in bigger chunks?
Buffering.
Exactly. So you wrap that file input stream with a buffered input stream. And that's a concrete decorator that adds buffering.
What if the data is compressed?
Then you can wrap it again, maybe with a zip input stream, which is another concrete decorator that handles decompressing the data. In this case, filter input stream acts as that abstract decorator class, providing a common base for all these different decorators.
You're building this processing pipeline, and each decorator adds a new step without the core file reading logic needing to know anything about those extra steps.
Yep. You can have just buffering, just decompression, or both in any order you need.
Super flexible. And you can even create your own custom decorators in java.io, right?
Oh, yeah, absolutely. Like, you could create a lowercase input stream by extending filter input stream and overriding the read method to change everything to lowercase as it's read. It shows you how powerful and extensible this pattern is. And by the way, the output streams like file output stream and buffered output stream, they follow the same pattern, as do the reader and writer classes for character data.
It's interesting. A lot of developers probably use these classes all the time without even realizing it's the decorator pattern at work.
Yeah, probably true. But once you understand the pattern, it makes the design of java.io so much clearer, even though it does have a ton of classes, which can be a bit intimidating at first.
Yeah, but that's kind of a general point about the decorator pattern, right? If you see an API with a bunch of classes that seem to do slightly different things, there's a good chance the decorator pattern is in play. And if you can spot those core components and the abstract decorator, it makes it easier to understand what's going on.
For sure. So for anyone out there who's thinking about implementing the decorator pattern themselves, what are some things to keep in mind?
Yeah, what are the key considerations?
Well, first and foremost, your decorators absolutely have to stick to the interface defined by the component. That way, you can use a decorated object anywhere the original one is expected.
So that substitutability principle is crucial.
Yep. Now, in simpler cases, where you might only need one level of decoration, you could skip the abstract decorator class. You could have the concrete decorator implement the component interface directly and hold a reference to another component.
So you'd cut out a layer.
Right. But generally speaking, having that abstract decorator gives you a better structure, more flexibility for future changes.
And it sounds like it's a good idea to keep your component classes pretty lightweight.
Yeah, focused on their core responsibilities, defining the interface and the essential logic. Don't try to cram in every possible feature from the get-go.
Right, it's better to start simple and add complexity with decorators as needed.
Exactly. Because if your base component is already really complex and feature-rich, then adding decorators might just make things more confusing. In those cases, you might want to consider a different pattern, like the strategy pattern. While decorator is about adding things around an object, strategy is more about encapsulating different algorithms or behaviors.
So you'd use strategy when the component has fundamentally different ways of doing something, rather than just needing extra features tacked on.
Right. Like in our coffee shop, different brewing methods might be better handled with strategy, while adding condiments is a perfect fit for decorator.
So let's bring this all back to the interview context. How does knowing about the decorator pattern help you impress those interviewers?
Well, it shows that you understand some fundamental object-oriented design principles, like the open-closed principle, the idea that you should be able to extend a class's behavior without modifying its code directly. Decorators let you do that. You can add new features without touching the core classes, and that demonstrates that you're thinking about building systems that are flexible, maintainable, systems that can evolve over time, and that's something senior engineers are expected to be good at.
So in an interview, if you get a design question where they want you to add optional features or maybe some cross-cutting concerns without messing with the core implementation, bringing up the decorator pattern can be a really good move.
Exactly. And being able to talk about the trade-offs too, the good and the bad, shows that you really understand the pattern deeply. It means you're not just throwing around buzzwords, you actually know when it's the right tool for the job and when something else might be better.
And that's what interviewers want to see, that you can think critically about these things. Okay, so to recap, the decorator pattern. It's a way to add responsibilities to objects dynamically by wrapping them with other objects. It's a more flexible and maintainable alternative to inheritance, especially when you need to add a lot of different combinations of features.
Yeah, it lets you compose behaviors in a really elegant way, and you avoid those massive class hierarchies that can be a real pain to deal with.
But as we said, there are trade-offs. You have to be aware of that potential for increased complexity with all those small objects. But overall, knowing this pattern and being able to apply it, it's a huge asset, especially when you're talking design in an interview.
Absolutely. It shows you understand composition over inheritance and those key software design principles that lead to more robust and adaptable systems.
Now, before we wrap up, here's the final thought for all you listeners out there. Think about a system you're familiar with, maybe a personal project or something from a previous job. How could you use the decorator pattern to add a new feature to that system without modifying the existing core parts? What would be the benefits? What would be the downsides?
And while you're at it, take a look at some libraries and frameworks you use regularly. See if you can spot any examples of the decorator pattern in action. Seeing how other people use it in real-world scenarios, it'll really solidify your understanding. And that'll help you not only talk about it confidently in an interview, but also recognize when to use it in your own work.
All right, that's all the time we have for today's deep dive. We'll see you next time.
See ya.